Hello, this is Old Electronics Fan, and today on the bench is my Heathkit condenser checker, as they call it back in the day, or as we would call it, capacitor checker. This little unit has two modes. It has measurement and it has leakage testing. And for those who are not familiar with these little guys, and I'm just going to bring that up a little bit. Let's just quickly look at the front of this. This is used for the measurement part, for resistance and capacitors. And I tested this with resistors and it was really good. Not so hot with capacitors, and I have a feeling that the fact that it's inaccurate has something to do with the problem that I'm having, which I will show you in a minute. This is the eye. This tells you what's going on, whether you're doing measurement or you're doing leakage test. This eye tells you the results of the testing. Down here we have the switch, which is called the power factor switch, but there's a switch in the back, which you can hear when I click it, that switches between paper and mica and electrolytics. Apparently electrolytics need more power to give accurate measurements. So when you flip the switch, it shorts across a couple of resistors, supplying more power to the tester, so you can get the correct reading from your electrolytics. Of course, this is where the test leads are going to go. The center pin is the positive. This is the capacitor pin. You put the caps here. If you're doing resistors here. This is important to know that this is positive, and if you're testing electrolytics, you must have the positive lead here and hook it up to the positive post of your electrolytic capacitor. Over here is the normal leakage switch. This is spring loaded, and it does it's supposed to discharge the capacitor after you do a leakage test, because you can go up to 450 volts that you can put on the capacitor when you're testing it. And the earlier ones had a manual switch that did not go back. You'd have to actually bring it back to where it would discharge the capacitor. This one automatically does it for you. And then of course this tells you, this is, call it the function switch, has the AC switch on the control. This is a dual wafer rotary switch. Part of the wafer has to do with the measurement part, and the other part of it has to do with the leakage test part. I can talk really. So stuff got on my meter, darn. Alright, so this something got splashed on here. I know it was clean at one point. Anyway, so I'm going to show you what it is that it's doing wrong, and then we'll open it up and we'll dig into it a little bit deeper. Alright, now I've got this set on 25 volts, and I do that and you see it closes. And I go to 150 and it gets even worse. That is a lie. That is not what I should be seeing. There's nothing on here. It should be, this eye should not be closing. I fixed this once for this problem. Don't know if I mentioned that. And at that time I found out that something I had sprayed on the control apparently was conductive and was causing this problem. I have since taken it apart again, and I used alcohol on it. And so anyway, for safety's sake, we're going to unplug you. I'll take it apart. Alright, so the control that I'm concerned about is right here. And let's see, can I get in here more? Alright, now, I was going to drag out the circuit diagram. Okay, I want to look at the circuit diagram, and I'm going to give a very quick overview. I'm not going to talk about the theory of this thing. Other people have done that and far better than I could. But it's relatively straightforward. This is the eye tube. This is basically what you call the data line. This is what feeds the grid of that tube and controls the opening. This is the leakage switch. It's in its normal position, and when you rotate the switch it turns in this direction. You know, arrow there that shows you that. This is the switch on the rear of the, I don't know if it's almost off the screen here. Alright, this is the switch on the rear of this leakage test switch, and it's showing it in the paper position right now, which puts this 470k ohm and 220k ohm into the circuit. When you go into electrolytic, when you turn this, I'm sorry, it's not the leakage switch, it is the, I think rain, it is the power factor control switch that has the switches on the back of that. I should know this by now, but anyway, okay. So down here you see the power factor control, which that's a variable resistor. So basically this is like a volume control with variable resistance for the power factor setting when you're testing electrolytics. And then it's got the on-off switch, is a double on-off switch on the back of it. So when it's set to electrolytic, the switches make contact here and here. This is shorted across and that is shorted across, which changes the amount of power that's being sent to this lead. Down here are the two wafers that are on the back of that upper right hand function switch. The bottom one has to do with the leakage testing. The top one has to do with measurement, and again the power factor control switch is also tied into there. Over here we have the power supply, which, by the way, if anybody knows why they used the 1626 as a rectifier, because basically they took a triode, 1, 2, 3, and turned it into a diode by shorting these two together. I'm not sure why they did it. It works. It does what it needs to do, but I just thought that was rather odd. Oh, and down here, I'll just mention this very quickly. I kept getting bit off from my capacitor tester, and I got tired of that. So I put a 3-pronged plug on here. I didn't need this capacitor anymore because now there was a ground directly to the chassis, and then this was directly to, this goes to the chassis. So I got that capacitor out of there, and now this plug makes sure that it gets plugged in the right way. It's grounded. If something shorts, then it'll trip the breaker. And so it's working well. I don't see anything wrong with this change that I made. I think it's working perfectly fine. So anyway, where am I? Okay, so and this main, just as a point of reference, this main control is that central dial that you use when you're trying to read the capacitors or the resistors. So anyway, back to the primary point here. So when this is in normal mode, these two are connected, these two are connected, and those are the only two connections that are being made in normal mode. So when you swing this to test mode, it now disconnects this connection here, which is a 55 volt line from down here, and it connects this with this. And what that does is that brings this into play in the leakage test mode. And then on this side, you see that this goes away because you're not going to be doing any measurement. You're going to be doing leakage testing. And so when you swing this over here, you make a connection between this, this, and this. And then, of course, this is the, if you want to call it the data line. It feeds the information or the voltage to the grid that tells you what's going on with the device under test. So when I was originally trying to troubleshoot this, I think my problem was, although I'm not 100% convinced, but I think my problem was, if I can stop hitting things moving around, is there was a high resistance between the here and here. So I got alcohol and a Q-tip and I cleaned this all up, and the problem seemed to go away. And unfortunately it hasn't stayed away, so I got to figure out why it has returned. What else do I want to touch on before we get into the unit itself? I can't think of anything right now. I guess I'll figure out what I forgot. Alright, so we're going to have to bring this into play, and alright. And that doesn't do much good if you can't see it, does it? Alright. Okay. Okay. Off camera, because I simply forgot to record it, I did a few things. I operated the controls. I checked to see if this was a high resistance connection here. I checked this one. I checked here when this was in normal mode, and everything looked fine here. I didn't see anything wrong. So what I've done is I decided I was going to start chasing this wire to see if for some reason something somewhere on this wire was wrong. You know, I was going to go down here, check the resistance chain, make sure this is the 25 volt setting down here. And this time, if you crank your knob, that would make this rotate down and connect to that resistor there, and that would put all this resistance in line, and you would get the correct voltage on your test connections. So I was going to start chasing this to see if there's anything on here. I don't know what, but if there's anything on here that could possibly be causing the problem. So I connected one lead of the meter here and one lead here, and I started checking, and I did, I believe, find something. I should only see a 220k ohm resistor. See what I see, and you can't see it. That's kind of annoying. Alright, that's better. Alright, now, actually, I'm going to back out here a little bit, and I'm going to swing this around, maybe. The wire that comes off from this switch up here, I noticed it had a crack in it. Yeah, that's not a big deal. Now watch this meter. By pulling it out of the case, I now see the 220k ohms that I'm supposed to see. I put it back in the case, and I can get meg ohms. I saw 500k there. Yeah, 500k, 490. I don't know if the wire has broken internally, or if it's, I don't know. So what I'm going to do is I'm going to stop. I'm going to replace this wire, and we'll check it again to see if indeed that was my problem child. I have to tell you, this is the strangest thing I've ever seen. I actually had disconnected this wire here, and I wasn't seeing anything wrong here, and I also spent some time with my meter checking to see if I really did have a high resistance connection between the pins when there shouldn't be any connection, and I wasn't finding that. I put my auto ranging meter on there, and when it's open, I didn't see anything that shouldn't be there. You know, in this case, you know, when you have this wire unsoldered, and you connect between here and here, you really shouldn't see much there, because there's a, well, anyway, I wasn't seeing the problem I saw earlier, because I was seeing a high resistance connection between here and here, which I kind of thought that I was seeing that again. When I didn't see it again, I freaked and said, wait a minute, this isn't right. Okay, yeah, you can see that. This is the wire I put in, and you'll notice my meter staying absolutely solid no matter what I do to that. Oops. My hand out of the way, you can see it. Nothing. So, what is going on with this? I don't know. Makes no sense to me. Come on. I'm really confused. I just don't get it. I can do whatever I want to with this wire. There's absolutely nothing. The only thing I could figure is the insulation had become conductive, and that it was connecting this to the chassis, but I don't know. But clearly, hook this up again. Yeah, it's behaving like it's supposed to. Oh, I forgot. I've got to put one more wire back in place. Let's see here. Or not. Alright. Bear with me here as I'm soldering iron. Okay, so what I need to do then is get this ready to go back in there. And we shall see. I guess now my idea was to test this before I went on camera, but you know what? I'm going to be brave. And we're going to see if this makes a difference. I don't know if it will. Alright, let's see. The insulation on these wires is starting to break down. So that's a matter of concern. So I'm gonna, yeah. Alright, do a final check here. That's working as it ought to. Okay. Let's see what we have got. Alright. Kill that. And plug it back in. Alright, so let me stop. Go. Oh, there we are. Okay. Alright. So this is set right. It's coming up. And that's how it's supposed to work. So let's just for fun check the capacitor. Let's see what we got floating around here. This is a 600 volt. Let's for those of you who don't know about these, the center pin is positive, and then of course resistors don't care, but capacitors do. So if you're testing capacitor, your positive lead goes to the center, especially when you're dealing with electrolytics. Paper caps don't care, for the most part. Well, they don't care. So anyway, so there's my brand new capacitor. And problem solved. I don't know. I just don't know. This is so beyond bizarre. Well, this is where assumptions come into play. Now let's just for fun, let's see, I don't remember if this was a bad capacitor or not. Let's see, let's put this on, well, it's 50 volts, so we gotta go down here. Alright, so that one isn't bad. I replaced it just because I think this was from my my web core. I know it's just the foil lens that doesn't really care. Yeah. So those are passing the test. Let's see, I know I have some around here. Aha! This should be a bad capacitor. Won't be it, but we'll see. Alright, 25 volts, 50. Yeah. So, my C3 is back in operation. That makes no sense to me. The only thing that makes sense to me is that this insulation had become conductive. Now, I don't know. I'm curious now. Let's see. Put that here. Put that there. Put that there. And move this out of the way. Alright. Okay. And I don't know if you can see that well very well or not. Alright. So let's check this out. I'll be darned. That was megohms. This insulation has become conductive. Really? That's megohms, but oh, this is not good. Oh my. Oh my. It's okay on that end. Well now. Something got into this wiring and made it conductive. That's crazy. So this stuff, I don't know if it was heat or chemicals or what, but the insulation on this wire is conductive. I was going to keep this around just for a piece of scrap wire, but I'm tossing it. I've never seen anything like it. That is brandy new. I never even thought that was possible. So, well, I'm glad I dug into this. I'm glad I found the problem. Not exactly what I thought I was going to find. But I hope that if someone else runs into this kind of a weirdness, that you'll check. And like I said, there were sections of the wire that looked fine. In fact, you could feel it. They were soft. It was soft. It wasn't conductive. And the brown sections were hard and were conductive. So that insulation, I don't know what they made that out of, but that's rather concerning. I've had this apart once before for this problem. I thought I had it fixed, as I mentioned before. And I'm checking this out here. Alright. Oh no. This is bad. Guess what? And these wires are all bundled together. And that's bad. I'm surprised this thing works. Of course, it's in the megohm range, but still. There's some funky things that have been happening with this. And well, that one seems okay. Let's see, go here. Yep, conductive. And it's megohms, but still, you don't really want that. You want your insulation to actually be insulating. Well, that's very not nice. Surprise. Well, guess I know what I'll be doing for a while. Replacing wires. Oops. In my C3. If I do that and I discover that it's working a lot better, I'll probably come back. But otherwise, thank you for watching, and this is something I have not seen. I've not heard anybody else talk about. I've never ever run into this before. And I guess it's not a surprise that my original repair didn't fix the problem, because it wasn't the problem. Oh boy. Well, I hope you learned something from this. I know I did. Maybe some of you already know about this. I did, sure heck didn't. And so I guess if you have this or something else, it has this funky wiring, funky insulation. Get out of there. This is a yellow wiring with little black stripes on it, and I'm assuming all these Heathkits use that same wiring, which means that this is probably not the only one that's doing this. So, have fun replacing your wiring. That's what I'm going to be doing. Thanks for watching. Okay. I wanted to show you what I did. I also wanted to come back and correct some of my previous statements about this wire. I mentioned that, you know, the brown areas were the conductive areas and the lighter colored areas that were softer aren't. Well, come to find out, that's not true of all the wires in this thing. Some of the wires, now when I initially tested some of these wires, I was seeing what I thought was k-ohms of around 70 k-ohms, but I went through all these wires again and I haven't been able to find the wire that was so low, but I was seeing stuff down in the 290k area, which in some circuits that's not good. That's really bad, and so you really don't want that. So what I've done though, so what I have done at this point is I've replaced wires like down here. These are the two filament wires going up to the eye tube, and these two wires go up to the eye tube. Or actually, the black wire, the blue, and the yellow, all those go up to the eye tube. I replaced all those. I replaced this wire that runs along the back side of the chassis. This one right here. And I don't know if this is a Heathkit wire that was sent out in their kits. This yellow wire with the black stripes on it. If it is something they've used in other kits, and I'm not, you know, I can't imagine why they wouldn't have. I don't know. But there could be other devices made by Heathkit that are having this problem. And this is a bear to troubleshoot unless you know what to look for. All right, so the wiring from the transformers is all good. This is transformer wiring. This is, I think. All this stuff is fine. This is a cloth covered wire. That seems to be okay. So, that's a new wire, that's a new wire. All the wiring. Now, here's what's interesting, except that you're not seeing much, are you? There we go. When I was playing around with this, I replaced this wire and this wire. And I placed and these yellow wires. And I stopped and I tested it. And the eye already looked better. I replaced this wire first, and it solved the problem kind of, but it didn't fix it completely. When I replaced all this stuff in this area and the one on the back here, that seemed to fix the eye and make it actually seem to be working like new. It's behaving the way it's supposed to. And so you'll notice that this is all new. So where we're at, let's turn this on, is we now have an eye that looks the way it's supposed to. And I actually, you know, they turn on better if you plug them in. Oh, stop, flashlight. All right. And that. All right. Okay. Let's see, can I? All right. Let's see if I can get this tilted up a bit. All right. Yeah, looks good. And we'll zoom in a little bit more here. Okay. Now, let me shade this again. All right. Now notice the edges of the eye tube. It's straight. It's wide. Before this area here that the eye covered or was not illuminated was smaller. So it was affecting the width of this. This was actually on the left side. On this side is actually curving. It would start out and it would curve down. Whoops, curve down, kind of around. It's very funky. And I kept looking at that saying, that doesn't look right. Well, it wasn't right. So this is what the eye is supposed to look like. And when you flick this, you will notice it will flash and it will actually get slightly larger. At least it does on mine. I'm assuming that's normal. You know, the tubes, this eye tube seems to have a lot. It's fairly bright, and so it seems pretty healthy. So I'm assuming the tube is not an issue. And you know, I did go through and replace the resistors and capacitors in this thing when I first got it. I think I checked the tubes. So as far as I know, this thing is now healthy overall. And so its behavior should now be what you would expect for a healthy C3. So my conclusion is simple. If you have one of these, or I guess any of the Heathkits that use this type of wiring, you need to check it out. Especially if it's a measurement device such as this, because it's going to mess with your day if you're trying to test using something that's simply not behaving as it ought to. Alright. So, the signs that this is not working properly, the eye won't look like this. It won't have nice clean edges. One side may curl in a bit. This angle will be narrower. And of course, a real key is when you have nothing on this and you do a leakage test and it's telling you that you have leakage. That's an instant clue that you have a problem. So check your wiring. Don't automatically assume that that's the issue. I believe that's probably going to be it, but check and make sure everything else is healthy. If you haven't worked on this on your device, if it's got the old capacitors in it and you're not sure of their health, it would be appropriate to replace those and check your resistance values. I was very fussy about those because this is supposed to be a somewhat precision measuring device. And actually, while I'm thinking about this, I want to see if we can check and make sure that this is now maybe measuring more accurately than it was. So let's see. Let me take a moment and we're going to see. Let's see, what do I got here? So this is a, to go to would be 0.02, I believe. No, it's 0.2. Yes. You would think, no, wait a minute, 0.02. I keep forgetting. All right. So this is supposed to be a 002 capacitor, and come on, let's go. And so 001 to 0.5. So that should be, and there it is, bango, dead on. I don't know if you can see, but that's almost exactly on the line. That's right dead on. Let's try another one. Let's see, do I have an 05? Let's try a different segment of the tester. What do we got? This is a 0.5, I believe. Yes, so this is a 0.5. Alright, and the range here is 0.1. Okay, so that says 0.5. Let's see. And that's dead on. Oh, there's one thing that you should know about these. One of the tests that this thing can do is it can test whether a capacitor is open or shorted. And you'll notice, and I don't think it does it up here, no it doesn't. So on the scale, the 0.1 to 50 down to the 0.001 to actually it's this one here. I think it does it on both. Yes, it does. Okay. So these three settings for capacitor testing will show you. So I've got this cranked all the way up to the top of its range, and the eye is open. What that tells you is you have an open capacitor. Now, if you have a shorted capacitor, notice that doesn't do that. Now I'm at the top end of my range, and the eye is opening. That means that the capacitor is shorted. And I think that's true, yeah, these three, and actually it's on all of them for that one. So if the capacitor is shorted, you're going to see that. If it's open, for some reason the top scale doesn't, this 20 to 1000 doesn't do it. But the other three scales, it will. So if you see that you're maxing out on the low end of the scale, you have an open capacitor. Top end of the scale, you have a shorted capacitor. And it is behaving like it's supposed to. And if I go back here, let's see here. And I've also discovered that this thing's a little bit funky. Let's see. Yeah. Oh, there it is. Yeah. It's right dead on. So, still a bit funky to use. And actually you can see that 0.5 maybe. That does say 0.5. If I'd only read my meter properly, it would give me the results. this thing is behaving really well now. It's not misbehaving like it was. Now here's a 005, it looks like. And let's see, and that means I have to go down here. Okay. Oh yeah, 005, there you are. And that is also right there. Yeah, I wasn't getting these results before, so I'm very happy with that. It looks like it's now working like it ought to. You can see I haven't used it for measuring capacitors very much. Probably, you know, who knows if I will or not in the future, but it's nice to know that it's much more accurate than it used to be. And you have to pay attention to your scales, and for some reason I was thinking that the .005 was down here, but I were wrong. There's a .005 in the middle, and there's one there on the bottom. So you can get the same measurement on two different scales, and sometimes you'll find it works better on one scale than another, but at least that was before I fixed it, so who knows, maybe it's going to behave itself now on all the scales. I hope so. Neat little machine. I'm glad that it's now working. Kind of shocked that the installation has gone south on these wires, and they're now resistors. Wire coverage with resistors. Pretty bizarre. So anyway, I hope you got some value out of this, and if you have one of these, a Heathkit product, and you're having weird problems with it, I would check the wiring. Thanks so much for watching.